Welcome to qnawire.
Okay, we have an electron in the 5f orbital. Right? So n equals 5. L equals, let's see, 0, 1, 2, 3, 4. Okay. And the thing is, we have to decide, we're given some other electrons and their shell and orbital, and we have to determine whether, like, what the relative effectiveness in terms of screening would be, right? Well, what's kind of the rules for screening in general? Things that are closer to the nucleus are better at screening, right? That's the first rule. Closer to nucleus. Okay, and the second one is less angular nodes. That's like the secondary. What that means is n is the most important number, the lowest n, and the second most important number is L. That is the like whether it's an S, a P, a D, an F, etc., etc., etc. So n, like the lowest shell, is always going to shield the best if you're comparing, like, say n equals. So here's an example. Like if we have I don't know, 2p versus that's not a very good example. Let's do this. Let's say 3s versus 2p. Okay. In terms of shape, the p is not as good at shielding as an s, but in terms of shell, n, 2 is lower than 3, and since shell is more important, 2p would be the better screener, right? So always look at the shell first and then the orbital type second. Okay. For that reason, you've got 5s, 5f, 2p, oops, not sp, 2p, and then 2s. Okay, so the best shielders are going to be the lowest shell, so that looks like these two. In between them, the best shielder is going to be the s, right? 2s, dang, I keep writing s. 2s is the best. Okay, and we know 2p should be right after that because its shell is lower than either of the 5s. Okay, now it's up to the 5s. They're both 5s, right? So they're tied in that respect, but then we look at the orbital type and we know that S has fewer angular nodes than F, right? So it's got to go 5S and then 5F.